أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنستكمل مع بعض موضوع local maximum and local minimum، ونتكلم عن absolute maximum and absolute minimum values to any function. هنتعرف مع بعض ازاي النهارده نعرف معنى كلمة absolute maximum أو absolute minimum value لأي function، ونشوف هنستخدم الديريفيتيف ازاي في إيجاد هذه الفاليوز. Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today is absolute maximum and absolute minimum values of any function. The absolute maximum and the absolute minimum on a closed interval. Definition: absolute maximum. Let the function f of x is defined on the open interval a and b. The absolute maximum value of f in this interval is the maximum value in the set of values of the function. Absolute minimum. Let the function f of x is defined on the closed interval a and b. The absolute minimum value of f in this interval is the minimum value in the set of values of the function. Now, calculation the absolute maximum and the absolute minimum. We use f dash x equals 0 or f dash x doesn't exist to get the critical points, say k1, k2, and so on to up to kn, such that k1, k2, up to kn belongs to the closed interval a and b. Number 2, find the values of f of x at these values of x belongs to the set of k1 and k2 up to kn, and the value of f of x at a and b belongs to the closed interval a and b. The third step, find the largest value, let it be L, thus L is the absolute maximum value of f in the closed interval a and b, and find the smallest value, let it be m, thus m is the absolute minimum value of f in the closed interval a and b. Now, the first example. Find the absolute maximum and the absolute minimum values of the function f of x, where f of x equal x power 3 minus 9x power 2 plus 15x in the closed interval 2 and 4. First, the function f of x equals x power 3 minus 9x power 2 plus 15x, and f dash x equals the derivative of x power 3, which is 3x power 2, and the derivative of negative 9x power 2, which is negative 18x, plus derivative of 15x, which is equal to 15. Now we put f dash x equals 0. Then 3x power 2 minus 18x plus 15 equals 0. Then by divide by 3, the expression x power 2 minus 6x plus 5 equals 0, and by factorize this expression, then x minus 1 times x minus 5 equals 0. Then x equal 1 or x equals 5. Now, x equal 1 belongs to the closed interval negative 2 and 4. But x equal 5 not belongs to the closed interval negative 2 and 4. Then we have negative 2 and 4 as a critical points, and x equal negative 1, which is belongs to this closed interval. Then we find the value of y at x equal negative 2. Then f of negative 2 equals negative 2 to the power 3 minus 9 multiply negative 2 power 2 plus 15 times negative 2, which equals negative 74. And f of 1 equals 1 power 3 minus 9 times 1 power 2 plus 15 times 1 equals 7. And f of 4 equals 4 to the power 3 minus 9 times 4 power 2 plus 15 times 4, which equals negative 20. Then we have three values, negative 74 and 7 and negative 20. Negative 74 is the smallest value and 7 is the greatest value. Then the point negative 2 and negative 74 is a point of absolute minimum. And the absolute minimum value equal negative 74. But the point 1 and 7 is a point of absolute maximum value. And the absolute maximum value equals to 7. Another example. Find the absolute maximum and the absolute minimum values of the function f of x equals x power 2 multiply e power x in the closed interval negative 3 and 1. F of x equals x power 2 times e power x is the multiply of two functions. Then f dash x equal the first function time multiply the derivative of the second, x power 2 multiply e power x, plus the derivative of the first, which is 2x multiply the second function e power x. Now put f dash x equals 0. Then x power 2 e power x plus 2x e power x equals 0. We can take e power x as a common factor. Then e power x multiply x power 2 plus 2x equals 0. Then x power 2 plus 2x equals 0, or e power x equals 0. E power x equals 0 impossible, because the exponential function is always positive, have a positive value. Then x power 2 plus 2x equals 0, and we can take x as a common factor. Then x multiply x plus 2 equals 0. Yes. Then x equals 0 or x equals negative 2. X equals 0 belongs to the closed interval negative 3 and 1. And x equals negative 2 belongs to the closed interval negative 3 and 1. Now, f of negative 3 equals negative 3 power 2 times e power negative 3 equals 0.45. The value of the function y equal 0.45 when x equals negative 3. And f of negative 2 equals negative 2 all power 2 multiply e power negative 2 equals 0.54. Then the value of y equals 0.54 when x equals negative 2. And f of 0 equals 0 power 2 times e power 0 equals 0. The value of y when x equals 0. And f of 1 equals 1 power 2 multiply e power 1, which equals 2.72 when x equal 1. Now we have 4 values to y. The smallest one is 0 and the biggest one is 2.74. Then the point 0 and 0 is a point of absolute minimum, and the absolute minimum value equal 0. And the point 1 and 2.72 is a point of absolute maximum, and the absolute maximum value equals 2.72. Now we move to the next example. Find the absolute maximum and absolute minimum values of the function f, where f of x equals 3 multiply square root of 4 minus x power 2 in closed interval 0 and 2. First, we have function f of x equals 3 multiply square root of 4 minus x power 2. The first derivative f dash x equals 3 multiply the derivative of the function inside the root, which is negative 2x, all divided twice the root. 2 multiply root 4 minus x power 2. We can simplify 2 from the numerator and 2 from the denominator. then f dash x equal negative 3x over square root of 4 minus x to the power 2. Now we put f dash x equal 0, then the numerator negative 3x equals 0 by divide by 3, then x equals 0, and x equals 0 belongs to the closed interval 0 and 2. Then we have two values of x, 0 and 2. We find the value of y when x equals 0, then f of 0 equals 3 multiply square root of 4 minus 0 power 2, which equals 6. And the value of y when x equals 2, f of 2 equals 3 multiply square root of 4 minus 2 power 2, which equals 0. Then the point 2 and 3 is a point of absolute minimum, and the value absolute minimum value equals 3, and the point 0.6 is a point of absolute maximum, and the absolute maximum value equals 6. Another example. Find the absolute maximum and the absolute minimum values of the function f, where f of x equals x plus 1 over x plus 2 in the closed interval 0 and 3. First, we have f of x equals x plus 1 over x plus 2, then f dash x equals the derivative of x equals 1, and the derivative of 1 over x power 2 is negative 1 over x plus 2 all power 2. We put f dash x equals 0, then 1 plus negative 1 over x plus 2 all power 2 equals 0, and negative 1 over x plus 2 all power 2 equals negative 1. Multiply, cross multiplication, then negative x plus 2 all power 2 equals negative 1. Multiply both sides by 1, then x plus 2 all power 2 equals 1. We factorize, then x plus 2 equals 1 or x plus 2 equals negative 1. Then x equals negative 1 or x equals negative 3. Note that x equals negative 1 not belongs to the closed interval 0 and 3, and x equal negative 3 not belongs to the closed interval 0 and 3. Then we have two values of x, 0 and 3. Now the value of y when x equals 0, which is f of 0, equals x or 0 plus 1 over x plus 2, 1 over 0 plus 2 equals half. And f of 3 equals 3 plus 1 over 3 plus 2 equals 16 over 5. We note that the value half is the smaller value and 16 over 5 is the greater value. Then the point 2.5 is a point of absolute minimum, and the absolute minimum value equals half. And the point 3 and 16 is a point of absolute maximum, and the absolute maximum value equals 16 over 5. Now we move to the next example. Find the absolute maximum and the absolute minimum values of the function f, where f of x equals sine x plus cosine x in the closed interval 0 and 2 pi. Now we have trigonometric function f of x equal sine x plus cosine x. First, we have f dash x equals the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Then f dash x equal cosine x minus sine x. Now put f dash x equals 0. Then cosine x minus sine x equals 0. Then cosine x equals sine x. By divided cosine by both sides by cosine, then tan x equals 1. When tan x equal positive 1, then the angle x lies in the first quad or in the third quad. Then x equals pi over 4 or x equals 5 pi over 4. Now x equals pi over 4 belongs to the closed interval 0 and 2 pi. And when x equals 5 pi over 4 belongs to the closed interval 0 and 2 pi. Now we substitute in the original function by 0 and pi over 4 and 5 pi over 4 and 2 pi. Then f of 0 equal sine 0 plus cosine 0 equals 1. And f of pi over 4 equals sine pi over 4 plus cosine pi over 4 equals root 2. And f of pi over 4, 5 pi over 4 equals sine 5 pi over 4 plus cosine 5 pi over 4, which equals negative square root of 2. And f of 2 pi equals sine 2 pi plus cosine 2 pi equals 1. Now we have 4 values. The largest one is square root of 2 and the smallest one is negative root 2. Then the point 5 pi over 4 and negative root 2 is a point of absolute minimum value, and the absolute minimum value equals negative root 2. And the point pi over 4 and root 2 is a point of absolute maximum, and the absolute maximum value equals square root of 2. If the function f is differentiable at x1 and the first derivative equals 0, f dash x1 equals 0, then it's not necessary that x is a point of local maximum or local minimum. For example, f of x equals x to the power 3. And another note, it may be happen that x1 is a local maximum or local minimum of the function f, and f dash x doesn't exist. For example, f of x equals absolute x. Example, find the local maximum and the local minimum values of the function f, where f of x equals 4x over x power 2 plus 4. The function f of x equals 4x over x power 2 plus 4 is a quotient and its domain equals R. F dash x equals 4, which is the derivative of 4x, multiply x power 2 plus 4 minus 2x, which is the derivative of x power 2 plus 4, multiply the numerator 4x, all over x power 2 plus 4 all power 2. We can write this function f dash x as 4x power 2 plus 16 minus 8x power 2 all over x power 2 plus 4 all power 2. Then f dash x equals 16 minus 4x power 2 over x power 2 plus 4 all power 2. The second step, we put f dash x equals 0, then the numerator 16 minus 4x power 2 equals 0. And we can write 4x power 2 minus 16 equals 0 and divide by 4, then x power 2 minus 4 equals 0. This expression is the difference between two squares, then the two brackets x minus 2 times x plus 2 equals 0, and x equal 2 or x equals negative 2. Now we draw the number line from negative infinity to infinity, and x equal negative 2, and the value of f dash 2 negative 2 equals 0, and when x equal 2, f dash x equals 0. Now, in the open interval negative infinity and negative 2, f dash negative 3 equal 16 minus 4 multiply negative 3 power 2 over negative 3 power 2 plus 4 all power 2, which equals negative 20 over 169, and this value is smaller than 0. Or f dash x is negative in this interval, then the function f of x is decreasing in this interval. In the open interval, negative 2 and 2, f dash 0 equals 16 minus 4 times 0 power 2 over 0 power 2 plus 4 all power 2 equals 16 over 16 equals 1, which is bigger than 0. Then f dash x is positive in this example, and the function is increasing in the open interval negative 2 and 2. In the last interval, open interval 2 and infinity, f dash 3 equals 16 minus 4 times 3 power 2 over 3 power 2 plus 4 all power 2, which equals negative 20 over 169, smaller than 0, and the function is decreasing in this interval. When x equals negative 2, it's a point of local minimum value, and when x equals 2, it's point of local maximum value. Now, at x equal negative 2, it's a point of local maximum value, and f of negative 2 equals 4 multiply negative 2 over negative 2 power 2 plus 4, which equals negative 8 over 8 equals negative 1. Then f of negative 2 equals negative 1 is a local minimum value. At x equal 2, it's a point of local maximum value, and f of 2 equals 4 multiply 2 over 2 power 2 plus 4 equals 8 over 8 equals 1. Then f of 2 equals 1 is a local maximum value, and the 2 points negative 2 and negative 1 is a critical point and is a point of local minimum value, and the point 2, 1 is a critical point and a point of local maximum value, and the 2 points is critical and local minimum or maximum. Then we have now the increasing and decreasing of the function and the local maximum and the local minimum values of any function. Now let us discuss the concept of critical point. Definition: we say that the point x1 and f of x1 is a critical point of the function f if one of the following satisfies. Number 1, the first derivative f dash x1 exists and is equal to 0, or f dash x1 doesn't exist or undefined. Then we can say that this point is a critical point in 2 cases. The first case, f dash x1 exists and is equal 0, or f dash x doesn't exist or undefined. Now, if the curve of the function f, where f of x equals ax power 2 plus 12x plus 1, has critical point at x equal 2, then a equals 12, or a equals negative 3, or a equal negative 6, or a equal 3. The curve of the function f of x equals ax power 2 plus 12x plus 1 has a critical point at x equal 2. The first step, we find the first derivative of this function. Derivative of ax power 2 is 2ax, and the derivative of 12x is 12, and the derivative of 1 is equal to 0 because 1 is a constant function. Now, the curve has a critical point, then at x equal 2, then f dash x equals 0 when x equal 2, or f dash 2 equals 0. Then 2a multiply x or multiply 2 plus 12 equals 0. Then 4a equals 12 0 minus 12, then 4a equals negative 12 by divided by 4, then a equals negative 3. Then we can choose the answer B. Then when the function has a critical point, then the constant a must be equals negative 3. بكده أعزائي نكون استعرضنا مع بعض موضوع absolute maximum value absolute minimum value. عرفنا ان لو عندي فانكشن والفانكشن دي ليها دومين او هو محدد لي دومين معين او closed interval معينه، اول حاجه بنعملها بندور على الفيرست ديريفيتيف، نجيب اف داش اوف اكس ونشوف الاف داش اوف اكس دي ممكن ايكوال 0 وان اكس ايكوال كام، ادور على الفاليوز بتاعت الاكس وبعدين اتاكد. طبعا هندرب الفانكشن ايا كان نوع الفانكشن، كانت الفانكشن بولينوميال، كانت تريجونومتريك، كانت اكسبوننشال، كانت لوغاريتميك فانكشن، ايا كان نوع الفانكشن. احنا اتعلمنا جميع انواع الديريفيتيف ممكن نعملها على اي نوع من انواع الفانكشنز. تطلع لي اف داش اكس دي فيرست ديريفيتيف، ابدا اخلي الاف داش اكس ايكوال 0. الايكويشن اللي عندي اللي هي الاف داش اخليها 0 ايكويشن واعمل سولفنج للايكويشن، بوصل لفاليوز للاكس، اكس ايكوال 1، اكس ايكوال 2، نيجاتيف 3، وات ايفر كانت الفاليوز بتاعت الاكس، وابدا اتاكد ان كل فاليو من دول belongs to للكلوزد انترفال اللي هو مديها لي. لو كانت موجوده في الكلوزد انترفال هي وبدايه الانترفال ونهايه الانترفال هنعوض بيهم في الاوريجينال فانكشن اللي مديها لي. لكن لو في فاليو للاكس مش موجوده في الانترفال هنتجاهلها ومش هنتكلم عنها في الموضوع. ونبدا بعد كده نشوف الفاليو بتاعت الواي او الاف اوف اكس لما الاكس ايكوالز البوينتس اللي طلعت معايا مع طبعا الانيشال بوينت والترمينال بوينتس بتوع الانترفال، واشوف اكبر فاليو بتبقى ابسوليوت ماكسيمم فاليو، واقل فاليو اصغر فاليو فيهم بتبقى ابسوليوت مينيمم فاليو. وبكده يبقى انا حددت الفاليو اللي عندها الفانكشن ليها ابسوليوت ماكسيمم وابسوليوت مينيمم، وكمان عرفت البوينت اللي عندها ابسوليوت ماكسيمم وابسوليوت مينيمم بتبقى بكام. كل ده طبعا حسب